So let's take a look at creating a discrete random variable, and specifically what some of the properties will look like. So let x be a discrete random variable that follows the distribution as follows. We have the value and we have its respective probability. Find the value of k that makes this a valid probability model. Now, this is always going to be the key thing here, very similar to checking our conditions. We have two conditions for valid probability models. As a reminder, the first one is that all probabilities are between 0 and 1. And secondly, so this means they're all positive and either it has no chance of happening or it will happen. And then the next one is that the sum of the probabilities must always equal 1. Right, so the sum in our sample space will be equivalent to 1 if we were to add all of those elements up. So using this information here, we can do some nifty things. For example, notice that I have k here. Well, k is not going to help me. K doesn't really have a specific value yet. So let's find the value of k that would turn this into a valid probability model. So we're going to take 4k, we're going to take the other values, so 4k plus 3k plus 2k plus 1k. Well, in order to be a valid probability model, the sum of the probabilities must equal 1. Okay, so 4 plus 3 plus 2 plus 1, that'll give us 10k is equivalent to 1, which means the value of k that will make this an appropriate or a valid model would be either 1/10 or 0.10, which means I now have enough information to find the actual distribution here. So for example, for this distribution, I'm going to have the following. So my values do not change. I'll still have 5, 10, 15, and 20. But I'll take 4 times 0.1, and that'll give me 0.40. 3 times 0.1, that'll give me 0.30, and so forth. The pattern follows. All I've done here is substitute the k value for its correct output. Now, like we said, in order to find the mean, which is either mu of x or e of x, either notation doesn't matter. I'm going to say mu of x here. We use the following formula, x and multiplied by its relative probabilities here. And so now I'm going to sub in what I know. So the first x is 5 times 0.4. The second x is 10 times 0.3. Third x is 15 times 0.2. And the last x is 20 times 0.10. So this is saying that 5 will occur 40% of the time. 10 will occur 30% of the time, and so forth, at least for this model. Not always, but specifically for this model. So when I take this into my calculator and sum it up, I obtain the value of 10 here. And then, of course, this would be 10 whatever, so here it's going to be 10 units, because we don't have context for this variable. And as a reminder, the way we grade is that we look for what you are doing, so that's worth 1 point. And what does it mean? What does it look like? This is where you show your substitution or your work. And then lastly, your value. So the value, the work, the formula, and I guess the term. I don't really know what to call this, the statistic. But these are how we grade. We look at what are you doing, what does it mean, what does it look like, and then what does it come out to. So that's basically how I grade for my students. And then this one could be 2 points because context, but just a good rule of thumb. And in any math class, not just AP Stats specifically, but you really should always communicate these 4 things. Okay, so we have our mean here. Next, it tells us to find the standard deviation. So again, we use the sigma x. And in order to find that, we will take the square root of the sum of the observations minus the average, squared it, multiplied by the probability of its occurrence. And if I were to get rid of the square root, we would just have the variance, because this sigma squared is the variance. So we're going to find that by doing the following. So I'm going to put the square root here. My first value was 5 minus the mean of 10 squared, and notice its probability does not change. Then we're going to add it to the second x value and its difference from the mean times its respective probability. We're going to take the third value find its difference from the mean and take its probability. And then lastly, we're going to take the fourth value, find its difference from the mean, and multiply it by its probability here. And when I do all of this, I obtain that the sigma of x here for this distribution is going to be 5. And if I wanted the variance, right, I would just square both sides, which would be 25 here. So I have a mean of 10, I have a sigma or standard deviation of 5, and I have a variance of 25. And then lastly, just good old probability refreshers here. Find the probability that x is greater than 5. Okay, again, what am I doing? What am I looking for? A formula. So I have one of two options. The first one is I can just use the complement rule and take away the probability of being 5 or less. Here, though, that would just be 5. Or you can do the following. This is equivalent to taking the remaining summation of the values of 10, 15, and 20. So either one of those is correct, which takes us to our next step here. So if I go with the top method, that's 1 minus 0.40, or if you go with the bottom method, that's adding these three values. And either method that you choose, you'll notice that you'll obtain the same probability of 0.60 here. So again, what are we looking for? What does it mean? What does it look like? And what is its value? So that's how I'll be grading this section. But just in summary, we started off with our distribution. We have two conditions to check. Well, we checked here. Each probability is between 0 and 1, and the summation of these of the sample space of these probabilities is 1. To find the mean, we add up the product of an observation and its probability. To find the standard deviation, we take the square root of the difference between the observation and the average multiplied by its respective probability. That gives us the standard deviation. And then, faulty C units, whatever my units would be. And then to find the variance, we just square the standard deviation, or you could have gone backwards, right? You could have found the variance and then just taken its square root. And then lastly, some probability questions, since we do have a probability model here that we're able to use. So those are just some examples of random variables for discrete random variables.